Thank you very much for the kind introduction. Ladies and gentlemen, it's my pleasure to give you an overview today about the activities we've done in the Netherlands concerning the acquisition of point clouds for the whole country, and as well as the use of those point clouds to generate 3D geo-information, also for the whole country. So that basically are the two main items of my talk. I'll start talking about the national point clouds that we've generated, first going a bit into the history of airborne laser scanning, then spending some time on quality control issues, having a short look at new developments in lidar technology, but also reviewing briefly the dense matching technology, so generating point clouds from aerial images, and finally some thoughts about how to maintain all this, how to make sure your point clouds, your digital terrain models stay up to date. And I'll continue with some slides on the generation of nationwide 3D geo-information databases. First on the level of detail 1, so that's the kind of building models where buildings only have flat roofs. But of course, to make them more realistic, you would like to have the level of detail 2, where you really model the proper roof surface. And also there we're looking into an approach that could be used for the whole country. So let me start with a little bit of history on lidar technology, or laser scanning, or laser altimetry. There are many different words for it. The first flights were organized in Europe in 1988, actually by the Institute of Photogrammetry in Stuttgart, in cooperation with Optec, the Canadian lidar company, as well as Rijkswaterstaat, which is an authority under a Dutch minister for main infrastructures, and also responsible for the coastal defense. And so they were very much interested to test new technologies to acquire DTMs in the coastal zones. So the very first flights that combined GPS for positioning, INS for pose estimation, and laser ranging were done in the Netherlands. But at that time, the lasers didn't have the option to scan. They could only look down. And that's why the airplane needed to make a lot of turns to get a halfway decent point density across the flight lines. Of course, this is economically completely infeasible, unattractive, but for an experiment it was still okay, but it showed the power of this technology. So what you see here, all these dotted lines, it was the flight pattern of the